If you're an amateur astronomer in the Northern Hemisphere, the odds are pretty good you're familiar with the Ring Nebula, M57. It's a frequent destination for visual astronomers, and though it has a very small apparent size, it gets a lot of attention from imagers as well. What adjectives come to mind when you see the ring? One for me is tidy. The ring appears to be a tidy circle. Unlike many deep sky objects, it has fairly well-defined edges. Another adjective might be small or even tiny. The Ring Nebula's apparent size is just 1.4 by 1.1 arc minutes. This ends up being a fairly small object in most eyepieces and sensors. Certainly in this image from June 2018, M57 is a very small part of the frame, and this image is cropped as much as I could get away with without exposing too many flaws in the image. It was really far too small a target for my Stellarvue SV80, but as a beginner and at the time living in a yard surrounded by trees in most directions, didn't have a lot of familiar choices visible, so I chose M57. Fast forward to June 2021, and I have access to a telescope with a much longer focal length, and it's matched with a camera that produces a much finer image scale. Out of curiosity, I slewed the telescope over to M57 to see how it looked. I took a 15-minute H-alpha frame, not really expecting to see anything beyond a larger version of the familiar ring. Instead, I saw this. The ring had another ring around it. I was stunned. Although there are images showing the outer ring, I have not run across any before. It was a discovery made possible only because of my own ignorance. But even so, to me it was utterly new. I forwarded a screenshot to one of my imaging partners on this system and asked if he knew about the outer ring. Old pro that he is, he responded that it was a cool feature. Meanwhile, I'm still bouncing up and down in my chair, chanting, outer ring, over and over. Had my wife been awake to see this behavior, she would surely have had a concerned look on her face. I knew that I had to do a full image on this to see if I could bring out the detail in the outer ring while retaining detail in the inner ring. I knew this would be a challenge because that outer ring was quite a bit fainter than the inner ring, but I was really looking forward to the challenge. I collected H-alpha, O3, and S2 subs. The H-alpha and O3 were strong signals, and S2 was stronger than I expected, but still somewhat weaker than the others. I ended up collecting 20 hours of data on this and was ready to test myself. I first decided to try an HSO palette in the thought that putting hydrogen in red and oxygen in blue would create a sense of familiarity. But as it turned out, my first attempt to bring out the detail in the outer ring wasn't very successful. It was hard to distinguish from the background. So I started over from scratch, and this time I used the SHO palette, also more familiarly known as the Hubble palette. My hope was that by putting hydrogen in green, I could create more contrast with the background. This had more success, but the need to stretch the outer ring so much really bloated the stars. This was progress, but it still wasn't what I was hoping for. So in the first two versions, I'd only done a single stretch, and then used HDR multiscale transform to try to tame that dynamic range. And that helped, but it wasn't giving me exactly the result I wanted, though I could get kind of close. I had really intended to use StarNet to remove the stars on two different stretches. One stretch would be for the inner ring, and another would be for the outer. However, in both of the first two attempts, StarNet kept leaving block artifacts, regardless of the stride setting I used. For the third image, I tried using mask stretch instead of histogram transformation, and again tried two stretches. This time StarNet cooperated, and I was able to use pixel math to composite the two images together. Then I was able to do a conventional histogram transformation on a copy of the unstretched original to get the stars to a level I wanted, and then pixel math those in as well. And all in all, it worked. It comes the closest to the vision I had in my head before I started. This ended up being the most complex processing I've ever done for an image. It pushed my skill to its limits, and realistically maybe a little beyond my limits. I ended up learning more about HDR multiscale transform than I ever expected. I now have a much better feel for the tool than I'd ever possessed prior to this. I also learned that StarNet is always incredible. Sometimes it's incredibly wonderful, and sometimes incredibly annoying, but it's always incredible. In retrospect, I see why people don't often do a tricolor narrowband version of M57. Oxygen and hydrogen really dominate. And while the S2 signal looks strong on its own, when you compare it with the others, you can see it's a lot fainter. I may eventually go back and do an HOO version from this data just out of curiosity to see what it would look like. That outer ring, it's really faint. It has at best a tenth the signal strength of the inner ring. It's tough to handle that much dynamic range. And I learned that the ring is still a small target even for a telescope with 2500 millimeters in focal length. I had to crop this fairly tight to give M57 some size in the frame. Overall, this was one of the more challenging images, perhaps the most challenging image I've ever done. But it was also one of the most rewarding, in that I was eventually able to find my way to a solution that did what I wanted, or at least most of what I wanted. And I learned something new. I had no idea about the outer ring. So that's the story of my discovery of the outer ring of M57, and my kind of masochistic challenge to try to tame that dynamic range and produce an interesting image. I hope you enjoyed it. Until next time, clear skies.